In order to run Road Plus, it is necessary to select the Advanced Project for Roads, where at the right you can find the automatic road calculation. The window will appear, as you can see here. From here, let's say that you can see that it is possible to switch straight away to our website, where you can download the file. The Excel file we use to input the information, and also the program we use to input all the results, is already available through a folder I have here. Which is this one. Let's open the file and let's analyze the different parts of the file. As you can see here, we have 3 sections. We have 3 pages. The first one is the main, where we input the information. The second one is the configuration, the CFG section, where over here you can have the description of the distribution of the luminaires. We can have yes or no if you have one way or 2 ways. The IP areas, which is the calculation about the Italian standard for energy efficiency of road lighting. But over here in hidden mode, we also have the section regarding the way to configure the ranges and some other features. If you have any need to change these parameters, can be done, but you have to ask OxyTech the command to open the section. At the end, we have the third page, which is regarding the examples. As you can see here, it is possible to input some empty rows without any information, which was not possible before with the previous version. The program used to stop in case of finding an empty row. Now it is possible to input an empty road, also already configured, but even a file which is not configured. Over here we have some examples about, for example, how to manage the ranges and how to manage the values. So let's analyze this one. In here we say that the height, the installation height, is 8, pipe 9.5. It means that we want to run a calculation with a height of 8 and another calculation with a 9.5 meter height. In this case, we have the range. So we have the square parentheses, 15 column 20, close the square parentheses, 2.5. It means that we ask the program to run the calculation for 15, the spacing interdistance, then 17.5, and then 20. As you can see here, we have the definition of the photometric file name. In here we have a simple photometry. In here we have a folder. It means that we have the main folder, which is this one, and then we have a subfolder at which we are going to input the photometries. So in this case, without defining any specific file, all the calculation will be done considering all the photometries included at this folder. In here, you see that it is also possible to define a single photometry included at the main folder, and all the photometries included at a subfolder. In here, you have the example about the selection you can perform using the asterisk. In this case, asterisk dot LDT means that you want to run the calculation considering all the photometries in the LDT format, ULM.dat format. In here, we have the project name definition. If we do not define any name, then the program will automatically consider the name, merging together the description at the column 1, the column A, the column C, and the column D, all together, separated with a dash. In this case, it is the same, but all the project will be included at a subfolder starting from the main folder called in this way. And the name will be generated in the same way like the previous case. In this case, it is the same. In this case, we are showing that it is possible to define subfolders, and then at the end, the name of the project. When you define the name of the project, and let's say that you have different cases because you define the ranges, then it is the program that automatically will create a name in this way, but the second one would be the same name underscore 02 underscore 03, etc. So let's consider the example, but before that, let's go back and let's check if the folders were defined in the proper way. So we open, and we have this one, the photometries, and we have to define the main folder. So we copy path name, we come here, and we copy. You have to always add the backslash you have here. The same for the project. So we take the folder, we go back, projects, and we copy the projects. We also remove these ones. Okay. And again. Okay, so the main folders for the projects and for the photometries were defined. Now, let's come to the definition of what we want to calculate. So, we select for the carriageway an M3 class, C1, no, we want to have a C2, and for the sidewalk and parking lanes, we define a class of P3, one way, and the width of the sidewalk, the width of the parking lane, the width of the carriageway, the complete carriageway, the number of lanes, the central reservation, the other carriageway, there is no parking lane, and the sidewalk, for a total of 19 meters. Then we define here that the height should be 8 pipe. It's not necessary to input the space because the space is not considered by the program. So in this case, we are saying that we want to run the calculation in height of 8 and 9. Again, the spacing distance we place at 25. The tilting remains at 0. And we put the luminaires at a distance related to the edge behind 1 meter. And in this case, for the other, let's say that we put 1 meter above. The maintenance coefficient, 2 opposite rows. Okay. And the definition of the name of the photometry. In this case, we want to use a single photometry, And this photometry is a photometry including an image and a spectrum at an OXL file. At the end, we define a name for the project, and that's it. So whenever we come to the AF column, we can consider concluded the data input for that case. So we go back, we define a section 2, via 2, and thread 2. So it is M1, C1, let's consider exactly the same. In this case, we are saying that we have a single carriageway with 2 sidewalks of 1.5 meters. Then here we have the height of 7 to 9 with a step of 1. It means that we're going to run the calculation at 7, 8, 9. Then a spacing interdistance of 15, a tilting angle of 0 up to 1 with a step of 0.5. So it means that we are running the calculation at 0, 0.5, and 1. Then the position of the luminaire transversally to the road, staggered rows, the photometry. In this case, we are saying that we want to run the calculation with all the photometries included at this folder, which means 2 photometries. Okay, and that's it. So we can consider that the data input is over, and we can start with the calculation. So we have to close the Excel file. We save. And we select Open File. Sorry, before we have to define which is the main file. So it is Road Plus UK. And now we open the file. As you can see, automatically the program created another file, which is the output file. So the program is not using exactly this one, but it is using a second file. So the first one will be Virgin. Okay, so let's open the file. We put it here, and let's expand the macro. As you can see, automatically the program is expanding the different configurations, and it's over. We can then start the calculation. As you can see, one by one, the program will run the calculation and fulfill the different cells with the related values. The calculation speed depends on the configuration of the road. So if you have to calculate on many different sections, it will take a little bit more than the simple road with a single carriageway. Let's say that we may have an average of, depending also on the computer, 5 up to 10, 20, maybe more projects per minute. So now it's over, the calculation were finished. We can close the window, the Road Plus window. We can take the Excel file and analyze the Excel file. As you can see, all the configurations that we gave are fulfilling the standard. And if you want to run a selection in function of different parameters, you simply have to highlight the line 13, and then you select filters and you apply the filters. So, for example, if you want to have a selection based on, I don't know, maybe on the EV minimum values, we simply select the minimum value or values, and automatically the program will filter. So we can come straight away to the configuration of interest, because now we go back to the project name. So it is the name Progetto Test. So we open the folder, projects. All the projects were done and saved here. Also in this way for the ones related to the subfolder. We take this one. We come out from the Road Plus calculation. We reduce and we open the file. Once you open the file, you can analyze it. So, for example, if we go and modify the road, we can come to the luminaires. As you can see, through the OXL file, we can have the image of the product, we can have the photometry, but it is also possible to analyze other data through the photo view. For example, the spectrum. As you can see, in this case, we have different spectrums because this luminaire was measured through a goniospectrometer. So we have all the spectrums related to the luminaire taken at the different C-planes and gamma angles. At the beginning, you also have the integrated spectrum. Through here, it is possible to analyze the photometry, the spectrum, from different point of view. So, for example, from the CRI point of view to the macadam ellipses, where you can have here the dispersion of the different spectrum coordinates and the ISTM 30 analysis. If we go back to the project, we run again the calculation. So here we have the check about all the different parameters related to the standard we are using. And from here, we can, for example, select this one. We select this one and select this one. We want to see the values. And in this case, we want to switch to Isolux curves. From here, it is possible to print the project.